Hi, this is the third video in the revision, the 1 hour revision playlist that we're looking at for the new specimen papers, which is the 9:1 new specification for AQA. This is the higher tier. Now, we have worked through up to the end of question 22, and we're going to be working through from 23 onwards. I'm going to aim for the video to be about between 20 and 30 minutes to give you the opportunity to stop each of the questions, have a go at them for yourself, and then compare your solutions. So please do have a look at the previous videos if you're not sure, and it always makes sense if you can to work through the rest of the paper in its entirety. Okay, so we've got here this centimetre grid, and we've got a shape drawn on the centimetre grid, and it says that we need to be able to work out the number of invariant points. So invariant points are points that don't move. Okay, so if we have a look at the first one, well, it says this shape is translated by this vector. So in other words, each of the points on here are going to move along 3 and up 1. So I can actually redraw this shape, and it's going to look something like that. So you can see here that all of the points have moved. Now, if they've all moved, it means there are no invariant points for the first one. Okay, so next one is where it's enlarged by a scale factor of 2. Okay, so if it's enlarged by a scale factor of 2 from the center 0, 0, it means it's going to look something like that. And you can see that actually all of the points have moved. That point's moved to there, that point's moved to there, that point's moved to there, except for one, which is the point at 0, 0. So the number of invariant points when it's enlarged by a scale factor of 2 is actually going to be 1 if it uses the center 0, 0. Okay, next one is that it's reflected in the line x equals y. Well, that line cuts across like that, so it's this line across here. So the shape itself doesn't actually change, but if we look at that, actually 2 of the points have moved because they've actually moved. It's reflected across, it's moved across to here, and that one's moved across here. The only points that haven't moved are going to be that point and that point. So actually, with this particular last one, the number of invariant points is going to be 2 on the very last question. I hope that's okay. Please do have a look at the dictionary definition of invariant points, and that should be able to help you with answering this particular question. Okay, let's move on then to question 24. This one is a velocity time graph. Okay, velocity time graphs do crop up quite a lot in most questions. They deal with most papers. They might deal with asking you about acceleration, which is what we're going to be dealing with in this particular one. Now, acceleration, it's one of the ways that you kind of need to remember it, I think, but acceleration, the unit of acceleration, or one of the units, is meters per second per second. Okay, so what it kind of reminds me a little bit, some people put this meters per second squared, but meters per second is velocity, and seconds is a measurement of time. Remember, it's per. Okay, so what we're saying is that acceleration equals velocity divided by time. Okay, and if we pop that in, we've actually got 2 bits of information. What we're saying is that it achieves 30, a velocity of 30 meters per second, and the time is 50 seconds. So the velocity is going to be 30 and the time is going to be 50. And if I divide that through, I can actually work that out as 0.6 meters per second squared. Okay, so that would be the answer to this particular question. It says shiv or give the units of your answer. So it's one of those things, I kind of remember it like that. I know that people use these kind of triangles where you get something like that, a I can't quite remember how it's drawn now, but you get something like A, and this divides up, I think, and you've got velocity and time or something like that. I'm not quite sure how it works, but for me, what I would always do is know the units of the answer, and that will then allow you to work through and come to a solution. So in this particular case, it's velocity over time, and that should work out as 0.6 meters per second squared. If you're not sure about how I've done that, the easiest way to do that would be to multiply top and bottom by 2, because if you do that, you get 6 over 10, and then it's just a case of moving the decimal point one place to give you that 0.6. So in this particular case, 0.6 meters per second squared. Okay, let's have a look then at the next little bit, and it says, this is again one of these fairly typical AQA questions where it's just a little bit difficult to kind of understand what they're getting at, but it says, estimate the time during the 50 seconds when the instantaneous acceleration equals the average acceleration. Well, the easiest way of doing that is actually to draw lines on the graph, because what we've got is a line between there and there, okay, which is basically what we've worked out when we've worked out the acceleration, because we've looked at the value of velocity divided by time. So it's the same effectively as gradient. It's the difference in y divided by the difference in x. So if we draw parallel lines, there is a point round about here where if I drew a line like that, there is a point at this point where the acceleration at that point is going to be the same as the average acceleration, okay? And that point, I kind of worked it out as 13 seconds on my graph, okay? But I think they will accept anywhere between 13 and 15 seconds, okay, at that point. So you need to just have a quick look at that and see if you can figure it out. It's probably, I reckon it's about 13 seconds, which is about there, okay? And the way to achieve that is to use these parallel lines. So a little bit of a tricky one, worthwhile maybe just checking and having a go and see if you can find some other questions which are relatively similar to these and checking them through and make sure that you're comfortable with these sorts of questions. Okay, let's move on then to question 25. Now question 25 deals with these functions. They're called functions, okay? This one I think is a little bit tricky for the 2 marks, but basically what they're doing is they're saying that you've got a value of fg of x and you've got a value of f and a value of g. So basically what I'm going to do is I'm going to take that value of g and I'm going to plug it into here, because that's what this tells me. It's taking that value of g, whatever that value is, and then taking it and plugging it into the next function. So in other words, what I can do is I can write fg of x as taking this bit and putting it into here. So I've got g of x, which is this, and I'm going to take that and I'm going to take it to the next function, which is the f of the result, if you like. So I'm going to put that into here. So what I end up with is 2 times cx plus 5, okay? And that's also then going to be plus c. So this bit has been put into this value of x. If you have a look at, there is a playlist actually on the channel that deals with looking at functions. It might be worthwhile having a go at that. So if I just expand that out, what I get is 2cx plus 10 plus c, okay? However, that's not what it tells us in the question. It actually tells us that this is 6x plus d. So in other words, this value 2cx plus 10 plus c equals 6x plus d. Okay, so, right, let's just be careful about that a little bit. So what we're doing is that we are working this out as this, and they're saying, oh, no, actually, it's this. So we're saying that in that case, that and that must be equal. We're also then saying that the coefficient of x, they're saying is 6, and we're saying no, 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 it's not, it's 2c. Okay, so let's just have a look at that. 2c must equal 6. Well, that's great news for us, because then it allows us to work out that c equals 3 if 2c equals 6. Okay, we're also then saying that the value of d must be 10 plus c. Okay, so the value of 10 plus c must equal d. Well, that's fine, because we've got the value of c, which is actually 3. So 10 plus 3 must equal d, so d must equal 13. Okay, so a little bit trickier with those, I think, and the main thing to be confident in what you're working out here, and then take that confidence and actually say, well, in that case, the coefficient of x must be equal to 2c, because that's 2c times x, and that's 6 times x. Well, that's fine, allows us to work out c. And then also say the bit that's left over, which is in their case d, must be equal to 10 plus c in this particular case, or 10 plus something. So we can, by inspection, work out the value of c and the value of d as being equal to 3 and equal to 13. Okay, so these type of questions are quite tricky. We are at the final bits of the question here, of the paper here, so they are going to be a little bit more challenging. However, hopefully you'll be able to pick up some marks from having a go at some of these questions, and please do have a look at the functions playlist on the channel, and you might get a little bit of an insight into dealing with these sorts of questions. Okay, so the next one is pretty much a favourite, whether you're doing an Excel or AQA, but they have these rationalize the denominator and simplify. Okay, rationalize the denominator. Okay, it's just one of those terms that they use. It just means make the bottom number whole, make bottom number whole, a whole number. So at the moment it's a combination of a whole number and a surd, but we're going to change that to make it whole. Okay, so what I'm going to do is I'm going to say, well, in order to do that, I've got 10 over 3 root 5. If I multiply the bottom by 3 root 5, then I've got root 5 times root 5 is going to be 5. Well, that's brilliant. So I've then got 3 times 3 is 9. So I've got 3 times 3 is 9. 9 multiplied by 5 is going to be 45. So it makes my bottom number 45. That's a great start. That's what I'm looking for. Okay, but with all of these things, if I multiply the denominator by 3 root 5, I have to multiply the numerator by 3 root 5. Well, that means that I end up with 30 root 5 at the top. Okay, now that would probably give you 1 mark. The only thing left to do with that is just simplify it a little bit more. I've got 30 and 45 here, so I'm just going to simplify that to 2 over 3 root 5, and that would be my answer. Okay, because 30 and 45 are both divisible by 15, so 15 goes into 30 twice and 15 goes into 45 3 times. Okay, hope that's all right. Please do add a comment if you're not sure about that. And again, there are some videos within the channel that will give you some practice on rationalising the denominator. Okay, last little bit, or last but one question is question 27, which is convert that to a fraction in its lowest terms. Okay, what we normally do with these, and there is a set technique, is we say n equals 0.1727272 recurring. Okay. Now again, if you have a look, I've actually just posted some videos recently on this conversion of recurring decimals through to fractions. And I'm going to follow the same technique as I did before, which is to say 100n. Well, if I move the decimal place 2 places, I get 17.272727, and so on. And remember, the whole idea is you need to be in a position where the recurring bit of the fraction is one above the other. Now, it doesn't always work out, as you can see here with the first decimal place, it doesn't, but with the rest of them it does, because it means then that if I subtract one from the other, I end up with this value of 99n equals 17.1. That's really helpful for me, because then I can just divide through by 99 and I get n equals 17.1 over 99. Okay, now at that point you would have probably got a couple of marks, because they have asked you to simplify that, and also that one's a little bit of a mess because it's a decimal in a fraction, and that doesn't really work. You need to make sure that that reads as a proper fraction. So if you move the decimal point across one place, that would give you then 171 over 990. Okay, now a little trick here is that they have asked you to convert it to its lowest term, so I'm fairly sure I can reduce that. Now what I'm going to do is, if I add up each of these digits, I get 9. 1 plus 7 plus 1 is 9. Well, 9 is a multiple of 3, so actually the trick here is I know that that is also divisible by 3, and that is divisible by 3. So actually what I can do with some confidence is I can write 3 into 171, and if I work that out I'm going to get 57. So I can write that as 57 over 330. Okay, and then again I'm going to perform the same trick. 7 add 5 is 12. That's also a multiple of 3. So 3's into 57. Well, that's actually going to be 19. So I can reduce that to 19, and the bottom one would be 110. And at that point I'm going to stop, because this is an odd number. It's also not divisible by 3, and this is an even number, so therefore I can't really go any further with that, and that would give me the solution to that particular question. So 0.172 recurring as a fraction in its lowest terms is 19 over 110. Okay, so we're on to then the final question in this particular practice paper. I hope you've been doing okay with these. They do take a little bit of working through, particularly this final video. And this particular question is asking you to work out the coordinates of Q, in other words, work out that. Well, there's a fair bit of work that needs to be done with this, because it's telling us that we've got a circle, x squared plus y squared equals 10. Well, don't forget that 10 is the same as r squared. Okay, so if I draw in here the radius, okay, then I could write that as the square root of 10. Okay, now it's also told me, and the reason I've worked across to p here, it says that p lies on the circle as an x coordinate of 1. Okay, so if I draw down to there, I've got that as 1, and then I've got this dimension here as root 10. So effectively, I've got myself a very small Pythagoras type question, where what I can say is actually what I've got is a right angle triangle where this is root 10 and this is 1, and therefore if I want to find out the y coordinate of p, which is this distance along here, then I can just use Pythagoras for that. So I could say that if I write this is A, and this, if you like, is B, and this is C, that's fine. I've got A squared equals B squared plus C squared. Okay, well, B is what I'm looking for, but A squared is going to be the square of root 10 is going to be 10. B squared plus C squared, well, 1 times 1 is going to be 1, so therefore B squared equals 10 minus 1, which is 9, and therefore B equals 3. So that's great for me, because I've actually worked out now that this coordinate of P here is 1, 3. Okay, so we're starting now to get a bit more information about this particular type of question. So if I've got this, it also then will allow me to work out the gradient of OP. Okay, now bearing in mind that this line along here is going to be perpendicular. Okay, so PQ along here is perpendicular to OP. Well, that's good because I know that the gradient of OP, so the gradient of OP equals the difference in Y divided by the difference in X. And I've actually already worked those out because the difference in Y is going to be the difference between there and there, which we've worked out as 3. It's this 3 here. And the difference in X is along here is 1. So it's going to be 3 over 1. So therefore the gradient of OP is equal to 3. Great. Well, that's a good start for me because then I know that because this is a tangent to the circle, I then also know that the gradient of PQ, so if I put gradient of PQ, that must equal the negative reciprocal of 3. So that's going to be minus 1/3. Okay. So I'm now starting to get a little bit more information about this type of line. So I've worked out the gradient of this, and that's going to be a gradient of minus 1/3. And I can use that information by plugging it into the general format of the line. A general format of any straight line is going to be y equals mx plus c. Now, I do know about this particular line. I know two things. I know the gradient. It's minus 1/3. I also know that on this line lies point P, which is the coordinates 1, 3. So I can use that information and plug it into this general format that when y equals 3, and the gradient is minus 1/3 and x equals 1, then the value of c I can work out. Okay, so I end up with 3 equals minus 1/3 times 1 is minus 1/3 plus c. Now, what I'm going to do is I'm going to add 1/3 to both sides. That means this value of c is going to be 3 and 1/3 equals c. Okay, now top-heavy fractions are not particularly useful for these types of questions. You need to convert that, I beg your pardon, mixed number are not so useful. You need to convert that, if you can, to a top-heavy fraction, which is 10 over 3 equals c. Now, bearing in mind this is the final question on this particular paper, so it is a little bit tricky, but now we've got two bits of information about the line. We know that it crosses the y-intercept at 10 over 3, which is this one here. Okay, and it's got a gradient of minus 1/3. Okay, so again, I can put that back into my standard form. I've got y equals mx plus c. Okay, well, what I'm looking for, don't forget, is I'm looking for this value of q here. Well, I know at that point that the value of y is going to be 0 because it's gone along the x-axis, but it's not gone north of that x-axis. It's actually just 0. So I can look at this again and I can actually put 0 equals, all right? Well, my value of my gradient we know is minus 1/3. And x is actually what I'm looking for, okay? So this value of x will give me then the coordinates for q because I know what y is, I just need to know what x is. And then I'm going to add that to 10 over 3, which is the value of c, in other words, the y-intercept. All right. So it looks a little bit difficult, but if you kind of work this through, what I end up with is if I multiply everything through by 3, I can, if you like, I can have nothing times 3 is nothing, and then I've got minus 1x plus 10 because I multiply that side, those two terms there, by 3, so those 3's disappear. I've also got this, which becomes 3 times 0, which is going to be 0. Okay, if I bring this now, remember that minus 1x is the same as saying minus x. Well, I don't really like minus x. I'm going to bring this term over to this side, so that's going to be x equals 10. Okay, and that's brilliant because now I've got the final solution where x equals 10 and y equals 0. So there's quite a bit of working through. I'm going to leave that on the screen. There's quite a bit of working through on this particular type of question, but it's recognising really that initially at least you've got this radius of the circle which is root 10. You can use Pythagoras to get this value, which is then the coordinate for the point P. So the coordinate for the point P now becomes 1/3. So what I'm doing is I'm kind of using all the information I've got to be able to get bits and pieces of information of this line that will tell me then this line. So if I know the gradient of this line, I also then know that this is the negative reciprocal, so therefore the gradient of PQ must be minus 1/3. And then really it's a case of using that information in the standard form of straight lines to be able to then calculate through and get a value of x is 10. Okay, now this particular type of question is 5 marks. It is quite challenging. There is quite a lot going on there. I have seen questions like this in other papers, so it might be worthwhile practicing if you can see any sort of similar questions. If you're not sure about anything, always please add a comment below. I'll come back to you. I look forward to seeing you in the next video, and there will be plenty more of these types of revision videos available on the site. So if you do get the opportunity, please subscribe, and I look forward to seeing you very soon. Thanks now. Bye-bye.